Hi. So here we are going to start with the introduction of 1B. We have already finished 1A, and this is an introduction of 1B. Let's see what we have here in 1B now. In 1A, we just saw what are irrational numbers and how to do decimals and everything. If you remember in the previous class which you guys have attended, we have already done how to show root 3 on the number line, or how to show that root 2 or root 3 are irrational numbers. Okay, here today we are going to do sums which are like prove that say prove that root 5 minus root 3 is irrational. So, in the previous chapter, we've already done um, a proof which is proof by contradiction. Now, you know what is proof by contradiction? Where we assume something and we prove what our assumption itself is wrong, correct? Whatever we have assumed, we end up proving it as wrong, and that is called proof by assumption, contradiction, sorry. So, here we are going to take, sorry. Here we are going to take let x equal to root 5 minus root 3, where let's take x is a rational number, correct? So what are we assuming basically? We are basically assuming that root 5 minus root 3 is a rational number. That is our assumption, correct? So therefore, if you square both the sides, okay, if you square this and this, if you square this side, what will you get? Let's see. So we'll get x square is equal to root 5 minus root 3 the whole square. Here don't multiply directly like this. Here we are going to use a minus b the whole square, which is equal to a square minus 2ab plus b square. So what do you get here now? See, therefore we will get x square is equal to root 5 the whole square minus 2 multiplied by root 5 times 3. Root 5 into root 3 will give you root 15, correct? Plus root 3 the whole square. So therefore we'll have x square is equal to 5 minus 2 root 15 plus 3. This 5 and this 5 and this 3 we can add, and it will be x square is equal to 8 minus 2 root 15. Now let's do one thing. Let's take the 8 on the other side. So we can take, or we'll switch this to this place. Okay, we'll take the x square here and we'll take the minus root 2 there, so that we don't get the negative number. So can we say that root 2 root 15 is equal to 8 minus x square, correct? That means root 15 is equal to 8 minus x square divided by 2. Now just observe this, what is happening here. X square, let us see, x square in this case, here in this part, x square, we know that that will give us a rational number, correct? 8, of course it's a rational number, right? And 2 here in the denominator is also a rational number. All right, so all your left hand side is rational number. What's happening on the right hand side? Right hand side, you have, this is root 15. And what is root 15? Root 15 is irrational. That means what are we trying to show here? We have shown that an irrational number is equal to rational value, which is not correct, right? This is not possible. It cannot be equal. Therefore, therefore, our assumption is wrong, correct? So therefore we can say that root 5 plus root 5 minus root 3 is a irrational number, because they have already said it's an irrational and we took it as a rational, correct? So therefore I'm just going to erase this and write, because this was only for your explanation. Okay, so just a minute. Are you guys getting it? Okay, so let's just draw a line here, and we can say that um, mm, yeah. Okay, so I hope you understood what I said here. So we have that since all of RHS is equal to rational and LHS is equal to irrational, correct? Therefore, rational, or rather because it is irrational, cannot equal rational, we can say. Therefore, irrational cannot be equal to rational. Thus, our assumption is wrong, and therefore root 5 minus root 3 is an irrational number, correct? This is exactly how we can do all the other sums. I'm going to do one more sum here as a sample, and then others you can try out in the exercises. Such sums are there. Okay, let's take one more sum. Let's take that prove that root 8 plus 5 is irrational. So what will you do here? Simply again you will say let x equal to root 8 plus 5. And what is x? X belongs to rational number, correct? Alright. Now you will square both the sides. What will you get? You will get x square is equal to root of 8 plus 5 the whole square. What will you use here? You will use a plus b the whole square is equal to a square plus 2ab plus b square. Perfect. So what will you get here? You will get x square is equal to 8 plus 5 2s are 10, and that gives you a 10 root 8, correct? Are you getting it? It is a 10 root 8. It is a root 8. I hope you guys are getting it. Alright, and this is going to be plus 25. That gets you what? That's get you 8 plus 25. That's a 33. X square is equal to 33 plus 10 root 8. What is 10 root 8? Can we write down 8? This 8 is actually 4 times 3. Correct? This 8 can be written as 4 times 3. No, sorry, 4 times 2. That means this is a 4 square. So 2 can come out there. Correct? So basically this, sorry, this number here 8, this can be written as x square is equal to 33 plus 20 root 2. I hope you know understood how you got 20 root 2, correct? Because this 10 root 8 we can write down as 10 root 4 into 2. 4 is 2 square, which will come out, correct? That's how you will get 20 in 20 root 2, correct? Now, so what you have here, therefore x square minus 33 divided by 20 is equal to root 2. Again we have landed into the same situation where our LHS is a rational number but our RHS is irrational, correct? Therefore LHS is equal to rational, RHS is equal to irrational, correct? However, we know that irrational is not equal to rational. Doesn't fit here. Sorry. So we know that irrational, therefore irrational is not equal to rational. Correct? Therefore, this contradicts our assumption. Correct? This contradicts our assumption. And what is our assumption? Our assumption was root 8 plus 5 is a rational number. That is our assumption. So we are contradicting our assumption. Therefore, we can say that root 8 plus 5 is irrational. Correct? Proved. Alright. Okay, so now let us see. I hope you guys understood this and you all do it by yourself. We will do a couple of questions from the exercise as well. But this is good. These examples are good. These examples are good enough if you understand them. And with the help of these examples, you can do the sums even in the exercise. Okay, all right. Now let's see whether we are able to suppose which kind of numbers are irrational. Okay, suppose we have a root of say 18, root of 18. Is this number an irrational number? How do you identify this? So let's write root of 18 as say 9 multiplied by 2. Correct? 9 is a complete square. That means this can be written as root of 3 square times 2, which is going to be 3 root 2. So basically this is 3 root 2 is an irrational number. Correct? This brings us to an understanding therefore that root 18 is irrational. Correct? Root 18 is irrational. Like that, alright, if we take say root 24, then what is root 24? Root 24 can be written as 4 times 6. That means there's going to be 2 root 6. 2 root 6 is irrational. So that means what? That means can we say that root 24 itself is irrational? So that means these numbers which will have these roots in between, the root signs in between, we can call such kind of numbers as irrational numbers, correct? Now, let us figure out if we are given two numbers, okay? If we are given two numbers, say 3 and 4, okay? And we have to insert two rational numbers, or let us say we have to okay, we have to insert two rational numbers, two rational numbers between 3 and 4. So I'm going to just show you this on the number line. That means they are asking us that, see, this is 3 and this is 4 on the number line. So we are also going to have 2 here and 5 here, but I'm not writing that, that is not required, correct? On the number line, this is 3 and 4. So they are actually going to be lots of numbers here, correct? We know that how this scale will look like. If you really magnify it, this is how something like this it will look like, correct? We have to identify two rational numbers between this, okay? So there are different ways of doing it. There is one method which is shown in your book. There is one method which I'm going to show you right now. Both methods will give you the same answer. So let's see, okay, how to do this. Suppose you want to find out two rational numbers, okay? So we need, if you need two rational numbers, you're going to do 2 plus 1, that will give you 3, correct? So what are you going to do? You're going to divide, you're going to multiply this side and multiply and divide by 3. So you're going to say multiply this and this by 3, and you're going to multiply this and this by 3. What is your outcome? This is 9 by 3 and this is 4 3s are 12 by 3. And now you can write as many numbers you want. 9, so you will get 10 by 3, 11 by 3. See, all of them are rational numbers, correct? So therefore two rational numbers, two rational numbers between 3 and 4 are 10 by 3 and 11 by 3. Or how you can write down, if you don't want to write 10 by 3, you can divide 10 by 3. So what will you get if you divide 10 if you divide 10 by 3, 3 3s are 9, remainder 1. So you will get uh, R 3 1 by 3, and this will be again 3 2 by 3. Correct? These are the two numbers. So in your book they have given a little different method where they say a rational number between a and b can be written as a plus b by 2. Okay, so I'll show you how they have done in the book. Okay, so suppose let us take 3 and 4, and we have to show two rational numbers. Right, so it will almost kind of give you a similar answer, but let's see how they do it. Okay, so on the number line, just I'll show you on the number line. They haven't shown a number line on the school book, but that's fine, we can show it. Okay, let's say 3 and 4. So they are saying that you should do 3 plus 4 divided by 2, that will give you 7 by 2. Correct? So 7 by 2, assume that is equal to 3 and a half. 3 and a half means it will come somewhere, 3 and a half will come here. Correct? Then you take this and this. Correct? That means you will take, see, either you can take 3 and a half, or you can take this batch. Okay, you find any number, one number here and one number here, it is going to give you two rational, because there are infinite numbers on a number line and you can get any two numbers. Correct? So therefore what are you going to do here? Therefore we can say, therefore sorry, therefore now this is one number, suppose you found out. Okay, now we will, let us take between 3 and 3 and a half, or 3 and 7 by 2, one number between it. So we can say 3 plus 7 by 2 divided by 2, that is equal to how much? 6 plus 7, that is equal to 13. 6 plus 7 by 2 divided by 2. Correct? That is equal to 13 divided by 2, and this 2 will also come up, which is equal to 13 by 4. So this was one number, and 13 by 4 is another number. 13 by 4 meaning how much? 4 3s are 12, remainder 1 1 by 4. So 3 1 by 4 and 3 1 by 2 are the two rational numbers between 3 and 4, and the one which we got were that was 3 1 by 3 and 4 3 2 by 3. Correct? Yeah, these were the two numbers we got. Both the answers are treated correct. Okay, but this is your school method, this is your school method. Alternatively, that was an alternate method that I showed you previously, but it's all allowed, that method is also acceptable. Okay, now like we show two rational numbers between any given two numbers, we can also show we can also show an irrational number, an irrational number between two numbers. This is extremely easy. So an irrational number between two numbers is, suppose you have a and b are two numbers, a and b are two numbers, then an irrational number between a and b will be root a and b. Correct? Irrational number between a and b is equal to root of ab. So therefore if you take 3 and 4, okay, or let us make a question there. So therefore an irrational number, an irrational number between 3 and 4, okay, that is equal to root of 3 times 4, which is equal to root of 12. Now basically root of 12 or 3, see 4 is a complete square. Correct? So we can, instead of writing out 12, I can just write this down as 4 is 4 is 2 square. Correct? So that means 2 can come out, it is 2 root 3. So this is one irrational number between 3 and 4. Correct? So this is your ultimate answer we can say for the question. All right, let's say um, let's take 2 short, oh wait 1 second. Okay, let's say that find one more example. This is find 2 irrational numbers between, this is between 2 and 3, between 2 and 3. What will you do here? See, 2 and 3 both are rational numbers, correct? Now okay, see, if you multiply 2 multiplied by 3 is equal to 6. Now if you see that 6 is not a perfect square. All right, 6 is not a perfect square. So therefore, uh, okay, anyway, so we have to find out, let us find the first irrational number. So first irrational number between 2 and 3 is equal to root of 2 times 3, which is equal to root of 6. This is your first irrational number, correct? And in that, now we have to find out irrational number between what? See, if you see the number line again, okay, let's say this is 2 and this is 3. So somewhere root 6 will be 4 point something. So sorry, 4, so 2 point something, so it will be somewhere here. So it is, suppose this is 2 root 6, okay, that means now we can find one number between 2 and root 6, correct? So that will be how much? Second irrational number will be what? Second irrational number between, it will be between 2 and root 6, correct? Which will be what? Which will be root of 2 into root of 6. This will be a, so therefore the required two numbers are, required two irrational numbers are root 6 and root of 2 root 6, correct? This is your final answer. All right, you guys will have to do a couple of sums by yourself, to get more clarity on that. Okay, all right. Now, most of the time when we do, there is a topic called rationalizing denominator in this lesson, where we have to use formulas which we have already seen in grade 8. Okay, those formulas are what? Very commonly used formulas, which are a plus b the whole square, which will give you a square plus 2ab plus b square. Then we have a minus b the whole square, which is equal to a square minus 2ab plus b square. And then we have a square minus b square, which is equal to a plus b into a minus b. Correct? Understand, girls, that left to right and right to left. Matlab, if this is given to you, we have to write this, or if this is given to you, we have to write this. Okay, vice versa, both ways, and we have to know and we have to observe this. Okay, that is very important. If you don't observe that what formula it is, then you will end up doing mistakes. I'll tell you how the mistakes are happening. These three formulas are eminent, very important for this chapter. I'm erasing it right now, but you guys have to write it every time. Even I'll write it and make sure. See, normally what happens, I write the formulas, students think what is easy, we will remember it anyway, but that is the exact place where you're going to do the error. You're not going to remember it. Okay, let's take one example. Let's take root 3 plus 2 the whole square, correct? So here what we have done, one sum before, correct? Here we have to use a plus b the whole square. This is equal to a square plus 2ab plus b square. That means what are you going to get here? This is your a, this is your a, and this is your b. Set them in the formula there and you'll get it. So you'll get root 3 square plus 2 into root 3 into 2, 2ab, okay, plus 2 square. Root 3 square will give you 3 plus 2 2s are 4. This will be 4 root 3, and again this will be 4. We can add these two elements. Don't do 3 plus 4, okay? This is wrong. You can't do it. Don't do 3 plus 4, 7, 7 root 3. No, we can't do that. 4 plus 3, this will be 12, and 4 root 3, it remains as it is. So this will be the final answer. Correct? Now, let's here itself. I'm going to do one more. Suppose, should I, one second. Let's take 5 plus root 2 into 5 minus root 2. So, what formula are you going to use here? We are going to use here a plus b into a minus b. Correct? That is equal to what? That is equal to a square minus b square. Now, if you actually closely see, this is your a, this is your b, this is your a, this is your b. What are you going to do here? A plus b into a minus b is equal to a square minus b square. What is your a square? A square will be 5 square, correct? Plus, what is your b square? B square will be root 2 square, correct? What do you get? 5 5s are 25 plus 4, which will give you 29. Okay, now I don't have space here a little bit. See guys, I want you to observe one thing, very important. When you use root 3, or when you use a plus b the whole square or a minus b the whole square formula, the final answer, you get an irrational number. Okay, but when we use a plus b into a minus b and we solve it further, we get a rational answer. Correct? This is an observation you must keep in mind. Okay, all right. uh, let's go to the next page. All right, next slide, I mean, and let's see that how we are going to figure out. Okay, here it is. Suppose we have we are going to now do a topic called comparing. Okay, this is all introduction of 1b. These type of sums are there in 1b. Okay, we have to compare. What we have to compare? We have to compare that the third root of 4 and root 3. We have to see which is greater and which is smaller, correct? We have to figure that out. Now, third root of 4. Third root of 4. Third root of 4 is actually 4 to the power 1 by 3. Okay, and uh, square root of 3 is written as 3 to the power 1 by 2. Correct? We have to see which is greater or which is smaller. To which what we are going to do? We will take the LCM of the power. Okay, here we are going to take LCM of the powers. Okay, so therefore we will take LCM of 1 by 3 and 1 by 2. 1 by 3 and 1 by 2. LCM is equal to 6. Right? And now if you cross multiply, if you take equivalent fractions, that means this will become 3 by 2, and this is going to become this will become 2 by 3, and this will become 3 by 2. I hope you guys understood. We have to make it equivalent fractions, correct? समझ में आ रहा है ना? ये बेबी स्टेप्स करने का टाइम नहीं है अपने पास. इक्विवेलेंट फ्रैक्शंस वी हैव टू डू. द डिनोमिनेटर हैज टू बी 6, so 1/3 multiplied by 2/2, that will give us 2/6. I wrote 2/3 by mistake, I'm sorry. Yes, and this will be how much? And we have 1/2 multiplied by 3/3. This will give us 3/6. Okay, so now we have to see this and this. So basically we can write down third root of 4/3 can be written as 4 raised to 2/6. Correct? And I'm going to shift this to here. Okay, 1 second. Okay, so therefore third root of 4 and we have root of 3. So third root of 4, now we can write this down as 4 raised to 2/6, and this we can write down as 3 raised to 3/6. Correct? So this we can write down as 4 square the whole raised to 1/6, and this we can write down as 3 cube the whole raised to 1/6. 4 twos, 4 fours are 16 to the power 1/6, and this is equal to 3 threes are, sorry, 3 to the power 3, which is 27. So this is equal to 27 to the power 1/6. Since the powers are same, we can compare the bases. So basically this is greater and this is smaller. And where did we come here? What is this ultimately? This ultimately is third root of 4 is less than root 3, and this is your final answer. This is how you compare. Are you getting it? All right. So let's do, there are a couple of sums there in the exercise which are not very difficult, very easy. So if we are going to go here, I am going to start with exercise 1b, and I'm not doing all the questions here because it's impossible. The first questions are easy. Choose multiple choice questions, I think it is very easy. We have, you can see, and they are kind of sums which you can easily solve. Okay, two rational numbers between 8 and 11, they have asked us. Okay, so I'm going to do in multiple choice questions. So question 1, okay, the rest are not very difficult, but I'm doing question E there. I think that probably can be a little challenging. Okay, they have asked us to do two rational numbers between 8 and rational, no, irrational, I'm sorry, two irrational numbers, two irrational numbers between 8 and 11. Now therefore what we are going to do, therefore first irrational number will be what? First irrational number, what is it? First irrational number is equal to root 88. Correct? Wait, they have given us some options below because it is 8 into 11, no? Remember A into B. 8 into 11, so it's equal to 4 root. So, my bad. Okay. So this is equal to root into 4 into 22. Correct? 4 into 2 is 2 root 22. Uh, they have given us an option here. 2 root 22. 2 root 22 meaning we have again have to find out. Okay, there's an alternate method to this. I think that is what we will have to use. We can't use this method. Okay. Anyway, I'll show you what is the alternate method to this. Okay. With first rational number and second rational number. This was the method that we had done. But with that method, there are 4 options given below. If you look at the textbook, okay, those options are not going to work out. Okay, so what we'll do, let us take 8. Okay, 8 is going to be root of 64. Okay, and let us take 11. 11 will be root of 121. Okay, so basically from 64 until 121, what are the numbers we are going to have in between? So we can have root of 65, root of 66, root of 67. This we can continue like that. Root of 82, root of 83, like this. Okay, continue up to root of 120 and root of 121, correct? But since we are not going to include 8 and 11, if you see the options given below in this textbook, they have given you 4 options. I'm going to write those 4 options here. Okay, what are the options they have given you? First option, they have given you root 65 and root 120, correct? Then next option they have given us, um, next option they have given us, this is I, this is root 69 and root, sorry, that is equal to 10.5. So this is equal to 10.5, and then this is equal to 8.2 and root 125, and this is equal to the fourth option they have given us is 3 and 3 and root 110. See, if you look very closely, okay, the first option will be the right option. Why? Because 65 from root 64 to 121, 64 and 120 will fall between 8 and 11, correct? So our first option, that is option 1, is the answer. Okay, rest all options, if you do 69, yes, 69 will come there, but 100, and if you see 10.5, 10.5, if the out of square, if you take inside square, what will that be? It will be 10.5 into 10.5, so it will be more than 100, correct? So that also could come this, but then this is a very outrightly correct answer. Okay, all right, let's see what we have. In the second question is very easy. I am just going to do, I think it's a pure use of formula, correct? Question number 2 in 1B. Okay. So we have, they have given you 4 questions. I'm going to do, I'll try and see if, okay, first question they have given, which is equal to 2 plus root 2 the whole square. Okay, so you know what we have to do, right? We have to use the formula, which is equal to a plus b the whole square, which is equal to a square plus 2ab plus b square, correct? That will be what? Therefore 2 plus root 2 the whole square is equal to, that's equal to 2 is of 4 plus 2 is of 4 root 2 plus root 2 into root 2 will give you 2, correct? This will give you 6 plus 4 root 2. This is the final answer. Pay attention, it's an irrational number. They have asked you that rational or not, so therefore this is equal to irrational. You have to mention that it is rational or irrational. Okay, now let's see. I think I'm going to do the third one, because the second one and all the others you can do as homework. That's just very similar, it has a negative sign in between. The third question is 5 plus root 5 into bracket 5 minus root 5. Now which formula are we using here? Which is equal to a plus b into a minus b, a plus b into a minus b, that's equal to a square minus b square, a square minus b square, that means this is equal to 5 square minus root 5 the whole square. 5 square is 25, root 5 is 5, your answer is 20. Final answer, this is equal to rational. Okay, now in this same question, okay, this the second part of the second question and the fourth part of the second question, you guys are going to do it as a homework. Okay, that's what it is. Let's go to the next type of question. Find the square of, it's very easy, it's the same thing. Question number 3 I'm going to skip, I'm not doing question number 3. Okay, or should I do it? One second, one question I'll do first sum. Okay, square find the square of. It is find the square of. See, they have given you 3 root 5 divided by 5. If you square this, you will get 3 root 5 multiplied by 3 root 5 divided by 5 into 5. So this will give you what? This 3 and 3. 3 threes are 9, and root 5 into root 5 will give you another 5, and this 5 fives are 25, or even if you keep this 5 like this. So this 5 and this 5 will cut, and finally your answer will be 9 by 5. Okay. Rest all questions are very easy in this one. This was the first part of it. Okay, this question that I did was the first part. So in this question also, if you see, it is just repetition of the second question, so we can skip it. Okay, the second part, the third part, and the fourth part, we have to do that as a homework. It's very easy. All right, overall this is these all questions are question number 4 is all true and false, so I'm not getting there. Question number 5 is also very easy, so that's kind of skipping off. I'm not doing it. And representing on the number line, I think that we have already done. Prove that are irrational numbers. You can do question number 7, you can try out and write in ascending order. In ascending order. Okay, I'm doing question number 14, because other questions we have done them. Okay, in example. Okay, we have to write down, write in ascending order. Okay, so they have given you 3 root 5 and 4 root 3. So what will you do here? 3 root 5 and 4 root 3. This is basically 3. Can we do take this 3 inside? See, this 3, we will take it inside the root, correct? So we can write down this 3. If you take it inside the room, it will become square. This will become 3 square times 5, and this will become root of 4 will become 16 times 3, correct? So this is equal to 9. 3 square is 9, so this will become root of 45, and this is going to be root of 48. See, we can write this as 4 to the power 45 to the power half, 45 to the power half, and 48 to the power half. Since the powers are same, we can compare the bases. Okay, so this is greater. From where has it come? Therefore we can say that 3 root 5 is less than 4 root 3. This is your answer, correct? I'll do the second part here itself. This was the first part, the second part in another color, so that you guys can understand, since drawing a line here is getting a little challenging. Okay, now we have 2 into the third root of 5. This is 2 into the third root of 5, and 3 into the third root of 2. So this will give you what? See, now because this is the third root, the third root, that means we have to take 2 inside the third root, that means we have to cube 2, correct? So this is going to be root of 2 cube into 5, and this will be root of 3 cube into 2. So this will be 8 into third root of, so this is third root of, okay, third root of, so this will 8 5s are 40 here, and this is going to be third root of 27 times 2, correct? This is third root of 40, and this is third root of 54. So this is equal to 40 to the power 1 by 3. This is equal to 54 to the power 1 by 3. Powers are same, so we can compare the bases. So this is greater. Where have we come from? We have come from our question where, which is 2 into third root of 5 is less than 3 into third root of 2. This is our answer. Getting it? That is how we keep on doing it, ascending and descending order. Okay, let's do question number 15. In the question number 15, we have to write in descending order. Descending order meaning first the larger number and then the greater number. Okay. So in the previous question also we had to write ascending, but we showed greater than and smaller too. But we can write it. I think I'm sure you guys know how to arrange it in the ascending and descending order. Correct? Okay. Question number 15. I'm doing part 1 of question number 15, and that is equal to 2 into fourth root of 6 and 3 into fourth root of 2. It is the fourth root of 2. That means we have to inside the root, fourth root, we have to take 2 to the power 4 into 6, and this will be inside the root, fourth root of 3 to the power 4 into 2. Correct? What is 2 to the power 4? That is equal to 2 2s are 4, 2s are 8, 2s are 16. So this is equal to 4 fourth power of 16 into 6, and this is equal to fourth power of 81 times 2. 3 to the power 4 is equal to 81. Okay, so this is equal to fourth power of 96, and this is equal to fourth power of 162. So we have to put it in the ascending order. That means first greater and then smaller. Which is the greater number now? See, this can be 96 raised to 1 by 4 and 162 raised to 1 by 4. Fourth power means 1 by 4, correct? Now, which is the greater one? This is greater one. We have to put it in ascending order, no, descending order, sorry. So therefore, we will write down this number will come first. That means which will come first? This will come first. Therefore, we have to write down 3 4 root 2, and the next number will be 2 into, sorry, this is not 3 to the power, this is fourth root of, okay, 2 into fourth root of 6. This is your order, correct? This is your final answer. All right, I think you can do the part 2, only part 2, and as homework, sorry. Okay, 5 irrational numbers between 2 root 5 and 3 root 3. What will you do here? Very easy. We will see which method we can use here. Okay, 16th question. We have to insert 5 irrational numbers between 2 root 5 and 3 root 3. So what are you going to do here? So given what numbers? Therefore we are given 2 root 5 and 3 root 3. Now see, 2 root 5 is out of the square. If you take, therefore we can say that 2 root 5, this can be written as root of 2 square times 5, which is equal to root 20. Correct? And 3 root 5, 3 root 3. 3 root 3 is equal to how much? This is equal to root of 3 square times 3. 3 3s are 9, 9 3s are 27. Now you have root of 20 and root of 27. Correct? Can we have, I'm sorry, can we have how many numbers we need? 5. Okay, 27. Let's put up 5 numbers in between. So we can say root 21, root 22, root 23, root 24, root 25. Is it will you say that root 25? Okay, one second. So root 25, root 26, and the last digit is root 27. The numbers in the white, we are not going to include them because we have to write numbers in between them. So the yellow ones are what we are going to consider. Now out of these yellow ones, you see root 25. This is not an irrational number. Don't write root 25 there, okay? This is not an irrational number. Correct? Root 25 is not irrational because root 25 will give you 5. So what will be your ultimate answer? Therefore, answer will be 1, 2, 3, 4 and 5. Don't write root 25. So root 21, root 22, root 23, root 24 and root 26. This is your answer. Correct? Similarly, you can do on the same concept. Okay, question number 18 is based. You can do it yourself. That is for homework. All right. I hope you guys understood what has been explained in this. Okay, the next topic that we will start after this is going to be surge radicals. A very interesting and very mechanical topic. It's very easy to understand. All right. So that's what it is. I hope you guys have understood what we've done in this. You guys have to practice, and if you have any doubts, you have to get back to me during the class, or you can message me, whatever it is. Okay, so then thank you guys. Bye bye.